Pode ir.
Hi everybody, my name is Lucas Vilela Encarnação. I am Associate Professor of the Federal University of Espírito Santo and a permanent member of the postgraduate electrical engineer program. And I'm here today for make a short video for Typhoon HIL in the concourse 10 for 10. Here this video will be divided in two parts. The first part will be an institutional part to explain how we work here in the university. The second part will show the infrastructure of the laboratory, and the third part will show a short application of a Typhoon HIL here in our installations. Okay? This is the first video, the institutional video, about the LEPAC, Laboratory of Power Electronics and Electrical Drive, and we'll talk also about the postgraduate program of Electrical Engineer and the Federal University of Espírito Santo. We start with a brief summary and some general information. We work at the Federal University of Espírito Santo, more specifically in the Electrical Engineering Department, in collaboration with the postgraduate program of Electrical Engineer. Our station work is the LEPAC, the Laboratory of Power Electronics and Electrical Drive. The Federal University of Espírito Santo was founded in May of 1954. It has 54 years old, has 4 university campuses, 103 undergraduate courses, 47 master programs of stricto sensu, 9 master programs of lato sensu, and 26 doctoral programs. The university has 1,780 full professors, over 2,000 technical administrative personnel, almost 20,000 undergraduate students, over 3,000 postgraduate students, and over 1,000 research projects in progress. The Electrical Engineering Department has 36 full professors that works at the electrical engineer, mechanical engineer, computer engineer, environment engineer, and architecture courses. The electrical engineering course was inaugurated in 1973 and has 80 annual vacancies for students. We have 1,000 graduate electrical engineer in the market, and we have 5 areas of expertise, like power systems, electronics, automation, telecommunication, combustion, and control. Recently, we have the highest grade at the National Student Performance Exam, the ENAD. The postgraduate programs of electrical engineer has 23 professors and has a master and doctor degree in electrical engineer. It was founded in 1991 for a master program and 1997 for a doctoral program. We have 65 annual vacancy for students, 45 master and 20 doctor, and we have degree 355 master and 104 doctors. We have 4 research groups: the energy, process and electric system, robotic controls and automation, telecommunication and information technology, biomedical engineer, and signal processing. Recently we are evaluated from CAPES as excellent course as national territory. The Laboratory of Power Electronics and Electrical Drive was founded in 1989, and we work here with undergraduate and postgraduate students. We have degree over 50 masters and 10 doctors. We have more than 50 research papers published in journals with high impact factor, and over 100 research papers published in renowned conference. We have some research fields here at LEPAC, like as power electronics, electrical drive, power quality, renewable sources, microgrids, and distributed generation. The laboratory has 10 professors and 47 students at the moment. We have 1 postdoctoral research, 16 doctoral students, 20 master students, and 10 scientific initiation students. We have some research projects in progress, like virtual single generator, multi-level converters, voltage positive sequence detectors, low voltage right tool for the FIGs, smart grid technology, impacts and solutions of distribution generator penetration, novel protection paradigms, and active features for amount mitigation. The last one is highlighted because we will show in the third part of this video an application of a Typhoon HIL with this team. The methodology that we work here at the LEPAC, we design new control strategies in simulation environment and validate these strategies in experimental environments. This is the methodology that we work today. We hope that we working with a Typhoon HIL, like with the hardened-the-loop real-time simulations, we can improve this philosophy of the laboratory. This is the second video. We talk about a little bit of infrastructure of the LEPAC. We here are in one environment of the LEPAC, and we will show three experimental setups that we are currently working today. The first one is the multi-level converter for electron drive. The second one is the DFIG for low voltage high through studies, and the third one is the active filter for harmonic mitigation that will show in the third video an application of a Typhoon HIL that we're currently working in the LEPAC. This is the third video, the Typhoon HIL application in the LEPAC laboratory. We choose the active filter for harmonic current mitigation for this application. In this simulation, this voltage source represents the distribution system. These harmonic sources represent the harmonic loads, and this power converter represents the active filter. And the strategy of control of the active filter was developed in C language in the Typhoon HIL environment. We start a play of simulation and analyze some results. For example, in this first window, we have in green the reference current calculated by the about the C code, and in red the current synthesized by the active filter. We observe that they have the same shape. In this second window, we can see in blue the harmonic load currents, in red the active current, and in green the source current, and we can observe that the source current has a sinusoidal form that was expected about the active filter. And in the third window we can see all the three currents of the three-phase system, all with sinusoidal forms, and all the harmonic was mitigated as expected.